So hello everyone and welcome back to my channel. So until now we have discussed about recursive Fibonacci series as well as the time complexity of recursive Fibonacci series. So we came to the conclusion that the time complexity of Fibonacci series is not O of 2 raised to n, but it is O of 1.6 the whole raised to n, which is a golden ratio. So that was our conclusion. If you haven't watched those videos yet, please, I'll be posting those links in the description below. I'll highly recommend you that you watch those videos before you head over to this one. Moving further, what we were actually discussing. We were now in this video, since we were discussing about recursive Fibonacci series, which is having a time complexity of 1.6 the whole raised to n, we need to optimize it till O raised to n with the help of recursion. How we are actually going to do that? So I'm going to help you with that. Let me just select the brush so that I could explain it in a better way, and that's how we start. So what is it? We have the function, you should never forget this one, which is f of n is f of n minus 1 plus f of n minus 2. This function is not going to leave you until and unless you're done with Fibonacci series. So it's always, you need to remember this equation. So we have f of n is equal to f of n minus 1 plus f of n minus 2. So let's say if you are calculating f of 5, what were the problems that we came across? So if in case we have f of 5, which will be further divided into f of 4, and then we have f of 3. F of 3 will be called later, so f of 4 will be called first, which will be further divided into f of 3, and then we have f of 2, right? And then f of 3 will be called, because always the left functions are called first and then the right ones. So we have f of 3 divided into f of 2 and f of 1, and then f of 2 further will be divided into f of 1 and f of 0. So this will be the very first function where we have the value 1. I've also explained you the functioning of how stack works. So if you haven't seen my previous videos, I'll be posting all the videos that will help you understand this paradigm. So then we have 0 here, so 1 plus 0 will get added in order to give you 1, and here we already know this is 1, and which will get added to give you 2, and then it will call f of 2 back again. So it has to call f of 2 back again, which will be further divided into f of 1 and f of 0, which is actually increasing our time complexity. So we already know f of 2 here, right? The value of f of 2, which is 1. Why we need to calculate it again? Bam! We don't have to do that. So hence, what we actually do is we use the process of memoization. Memoization. I hope the spelling is right. So what is memoization? Memoization is nothing but dynamic programming approach in which we create a lookup table, so which can be array in this case, and we maintain the lookup table in order to address the already mentioned values. That is going to fasten our process. So how is that gonna be? So if we have till f of 5, that will be, what will be the values that will be necessary? We have 0, then we have 1 again, we have 2, and then finally it will end up 3. So these are the 5 terms that we require. So hence we'll go from till n minus 1. So we'll create an array of size n minus 1. So let's say we have created an array with 0th location, like let's keep it as a stack pile. We consider it to be the stack for this matter, and then we create 5 boxes. So this is for 0th location, 1th location, 2, 3, and 4. That's still n minus 1. So we are gonna previously, as we already know, what's the first starting initial values? It's 0 and this is 1. So as we know the initial values, it will function as the way it is. The recursive function will function as the way it is. So it will start from f of 5, go to f of 4, then f of 3, then f of 2. We'll add up these values, and what we are going to do is, once we know f of 2, we are going to store that value here. So we don't know f of 3 here. So initially, we are going to set all of these values as -1. Currently, that's the approach I do. You can keep it anything. You can keep it min dot integer min value or min dot integer max value. That is going to be a reference value. And so moving further, what we need to do we know f of 3? So since f of 3 is still so since 3 is still -1, what it will do is it will calculate it recursively. So it will look for the values of f of 2 and f of 1. We already know the value of f of 2, which is 1. That is, through recursively we have got to know it. Or whenever it calls for f of 2, it will look back into the lookup table. It has got a value, so it will take f of 2 as 1, and since f of 1 is 1, it will add both of them, and it will give the value of f of 3 as 2. Finally, when we come back to f of 4, since the value of n is equal to 5, it will calculate till n minus 1 values, that are still the fourth value, because since we are starting it from 0. So if we want the value of fifth term of Fibonacci series, what I'm calculating here is not the fifth term, but actually 5 terms of Fibonacci series. So I'm going to send n minus 1 in my case. But so if you want till 5th term, then you should have 6 terms, right? So for 6 it will have another block. So for 5 it will have another block. So let us consider till f of 4. So in case of f of 4, what it usually does in the previous program of recursive function is it calculates f of 2. But that's not the case here. It will look for f of 3. Since f of 3 is already in the lookup table, it will take the value of 2, and then for f of 4 it also needs f of 2, right, in order to calculate f of 4. So it will look into the lookup table, add 1 and put 3 here. So for 5, if you want 5 terms, it will give you the value equal till 3. And you can print this array to get the result. In the next video, I'm going to help you write the code in Java to execute or to implement this, whatever I've taught. Thank you for watching. Please like, share and subscribe for more interesting content. Thank you and have a nice day.